Hello and welcome to video 13 in the introduction to our workshop series accompanying videos. These videos are run by the statistics unit at QIMR Berghofer, along with the workshops that we run. And there are the contact details for the statistics unit and all the services that we offer. So today we're going to be looking at some new stuff. This is from the fifth workshop, and fifth being in how we've set them up for this year. But this workshop is looking at material from this workshop. So it's looking at all the Tidyverse material, some of the Tidyverse material. So we'll be starting with the package dplyr. So that's dplyr. So make sure you've installed that package so that we can look at it a bit in this video. And we will be using that pulse data txt file that we've used in previous videos as well. So hopefully you've got all that material on your computer, you know where it's saved, you can set your working directory there. Hopefully you've also got a bit of an understanding of what R is, so this maybe isn't the best video to start up with. So hopefully you've looked through the material before, seen other videos or gone to the workshops. Okay, into the Tidyverse. And this is basically just section 21 from the booklet. So the Tidyverse is, broadly speaking, a large collection of different packages in R that all work together and complement each other. The main developer of the Tidyverse was this guy on the screen here, Hadley Wickham. Major big deal in the R and RStudio world. He developed a bunch of older packages used for visualization and handling data. So he's had a long track record of this. But Tidyverse was the big attempt to really make a vocabulary for dealing with data. So it's rather than using, in addition to just using function names, it was a way of combining the scripting and the coding of R with just how we talk about data and how we can communicate that to peers, colleagues, to make everything working easier. So the Tidyverse can almost be considered, it's a little bit like its own language now. It's a large subset of R. So all the Tidyverse is it's all separate packages. None of them really come with R by automatically. You have to get them through install packages. But there's just so much of it now, and it's being so used that it's almost like its own language within R. You can still interplay with older or more base versions of R, functions of R, and some other parts that aren't part of the Tidyverse. It all still works together, but the Tidyverse way of doing things is fast becoming a very popular way of working in R. So there are some things to sort of forget as you move into the Tidyverse. So base R and the normal way of doing things in R depends a lot on what type of data types you're using and the function format. So we spent a lot of time on this and how functions are used in R. So the specific syntax of functions in R, where it has the function name, the arguments, and we talked about being aware of what type of data each of those arguments have to be and what type the output is. Often when we've been data cleaning or making new things with our data sets in R, we've been putting vector component inputs into the function. So we've been putting a vector of data in as the arguments, and we've been getting vector outputs or singular outputs. And that can be and that is actually a bit different in Tidyverse. So the focus of Tidyverse is just make everything simple and straightforward and have a really good workflow. So it's getting data in whatever format and then changing it and tidying it up, getting the correct data, getting the transformations and the values that you need, and then doing whatever you need to do. So whether it's transformation, visualizations, modeling, just ways to really understand what your data is telling you, and then helps you tell other people what your data is telling you through communication. So there's a lot of focus on all components of that working together at the same time. So working together on transformations that's clear and understood amongst people, visualization to other people and stakeholders, and all that, also that modeling and analysis. So as I was saying previously, a lot of the previous functions had vector variable input, and they outputted a vector. So when we were changing a variable in a data set, we would give that variable to the function, we would change that variable, and then we'd have to override that variable in the data set. Or we made it a new variable in the data set. However, in Tidyverse, most of the functions will take a whole data frame as input. So rather than a vector, it'll take the entire data frame that you want. It'll make that change to the data frame, and then the output will be the whole data frame changed. So that when you really think about it, that is a little bit of a big difference between the two. And it's just good to be aware of what you're expecting to get out of the functions as you work with them. Another thing in Tidyverse is that you generally don't need quotation marks around column names in the data sets that we're working with. So in previous times when and not all the times, because we've looked at stuff like the function note, formula notation, when we use functions like that, we haven't had to always use quotation marks, but it's definitely a thing with the Tidyverse functions where, because you're giving the data set to the function can kind of figure out that, all right, this is the data set and this is what I'm expecting a variable name to be. I don't necessarily need quotation marks. So these are all just things to be aware of, that the stuff we're going to go into now is a little bit different than what we've looked at previously. But what we're going to do is we're going to jump into RStudio and have a look at some basic functions from one of the popular packages, Dplyr. Okay. So I've got my Pulse data set in my environment already. So I've looked at this a bunch of times before. We've used it a lot. And I've already used library to get Dplyr into my R session. So just because I used the install.packages function to get that package of software onto my package of code onto my computer, doesn't mean I can access it straight away. I do have to use the library function to get that package into my R session. So make sure you've done that and got Pulse data in using the read.csv or some alternative already. So as we're going to do, we're going to look at ways that we can use the tidyr functions to wrangle data. And wrangle is a term that's used quite a lot because it's, data can come in all sorts of weird ways, and we've got to try and push it and poke it and flip it and do all sorts of things to get into a way we want. The tidy in Tidyverse comes because we're looking to always have tidy data. Tidy generally refers to each row being a separate observation, and generally more likely to be long data where multiple observations from the same subject will be across multiple rows. As we all know, data sets don't always come that way. It can be all sorts of weird things. So all these functions that we've kind of already looked at before, all these concepts, Tidyverse has got a way of really fitting them all together. So the first thing we're going to look at from the Tidyverse or from the Dplyr package is making a subset of the data. And so this is done with the filter function. And we may have looked at this before. I think it was earlier in the booklet when we were talking about subsets. So the filter function, basically you really only need two inputs. It's very similar to the subset function that we've seen previously. So there's a .data input. So this is one thing to note. The first input is the data set that we want to work with. Technically, the argument name is .data, not just data. Normally, this wouldn't be a problem because, as we've seen in other previous functions, we can do the function without defining the argument name. So we could do this without having .data equals in it. But it's just in there for the moment to make the point that some of these Tidyverse functions, the argument names do start with that full stop. So it's good just to be aware of that and not ignore it or miss that. Anyway, so the first argument is the .data is our Pulse data frame. And the next argument is the logical condition that we're going to be making a subset on. In this case, it's height greater than 190 centimeters, or sorry, greater than or equal to 190 centimeters. Again, this is very similar to the subset function that we've seen previously. So highlight that line, Control Enter. And this is our subset of the students in our fictional data set that are 190 centimeters or taller. So again, the filter function is very similar to the subset function. You may ask if they're so similar, why do we have two versions of them? Basically because the filter function works with other functions in the tidyverse very well as opposed to the subset function in ways we'll see in the near future. We won't look at them right now, but that's why. So I guess the complement to filter is the select function, because the select function chooses columns to keep. So in the same way that we give the filter function a complete data set and then say which rows to keep in the output, the select function will be given a whole data set and then choose which columns to keep. So just like before, there's the .data input and the data set that we're working on. Then after that, separated by commas, is just the columns that I want to keep in my output. So I'm going to highlight that line, Control Enter, and I can see here that my data set in my output just contains those 3 variables. So filter and select are the 2 functions you use to make subsets or make just selections out of your data set. Okay, the next main verb. I say the word verb because a lot of these functions in dplyr are referred to as verbs. They're referred to like verbs are doing words, so you will filter something or you will select something. So these function names are given names that you can use in that sentence of like filter this, select this, etc. So sometimes they'll be referred to as verbs of tidyverse or verbs of dplyr. So the next function we're going to look at is the mutate function, and mutate makes variables. So you give it a data set and then you define what variables you want to add to that data set. So you can see here in this example, we've got mutate. The data that we're using is pulse data. Again, I don't need to have .data equals because I know .data is the first argument in the function. I could just write pulse data, but I'm just keeping it in there for the moment. And the variable I'm creating is this BMI variable. So I'm saying BMI equals, just one equals sign, and then I'm defining BMI by the weight and height variables that are already in there with this little formula. So weight and height are in there, and BMI is weight divided by height squared, where height is in meters. So there's a little bit of code that calculates BMI. And that will, if I run that line of code, it'll give me the entire output because these functions will output a whole data set with BMI now the last variable there. You may be asking at this point why we want to output a whole data set. Why not just output the variable that we add to a data set? Again, it may seem like not a major difference at the moment, but we'll talk about in later videos exactly how we can use this outputting a whole data frame. So to really compare it to, say, how we would have done this if we weren't using Tidyverse. Oh, oops, jump down here. So if we weren't using dplyr and we weren't using mutate, we would have done something like pulse BMI equals, sorry, would have done pulse weight squared. That's what we would have had to do previously, where each variable there has to be extracted from the data set. So weight and height both have to be taken out of pulse data to be used. Whereas with mutate, we're just saying, here is the data set. We're going to make a variable based on the information in this data set. This is the variables we're going to use there. We don't have to put them in quotations. We don't have to use $signs, and we can calculate things that way. So mutate can be really good if you're only working within a data set. If, say, you need to use a vector or variables from other data sets for some strange reason, normally that's a very strange thing to be doing. because all your information should be put together in the one data frame. You'd probably have to go back to base R and get really fancy with your code there. But because Tidyverse is designed to help you do the things you would normally be doing with a data set, which is making variables based on the information in your data set, transforming those variables, which is why I will just figure out that these variables are part of your data set and we'll look there for it. Also with mutate, you can make multiple variables at the same time. So in this code here on line 41, I'm making both the variable BMI, but also the variable weight underscore LB. So I'm calculating the weight in pounds. One thing to note, so obviously this line of code is creating BMI again. You may ask, haven't I already created that? Even though my output is a whole data frame or a whole data set, I'm not overriding the original data set here. So even though mutate, select, filter are all outputting a whole data set, that isn't changing my original pulse data object. I would still need to assign that whole data frame object to pulse data to update it. So you can see here, if I control enter, that now that output that has been printed to the console but not been overridden my pulse data object has BMI and also weight pounds at the edge there. Okay, another function that's very similar to mutate is transmutate. This makes variables and makes transformations, but it only outputs those new variables. So it's kind of like doing mutate and select at the same time, where you mutate new variables and then you only select those ones to be kept for the output. So very similar to before, transmute data equals pulse data, the BMI variable code, control enter, and then only BMI is part of the output. So it's essentially like doing mutate and, sorry, I've got that wrong there, don't I? Transmute, not transmutate. BMI, sorry, transmute is like doing mutate and select at the same time. That may not be useful, you may not see why that's useful now, but that will, as we do other concepts in Tidyverse, you'll see why that may be useful. Okay, the last one we're going to look at here is the arrange function. So arrange is a function that arranges the data set. So again, we put a whole data frame object in there, and then as the first argument of dot data is the data set we want. Again, we don't need the dot data equals as long as we put the data set as the first argument. But every variable after that comma is the variable that arrange will arrange the data set on. So in this first line here, the output will be the entire data set arranged by age. So we get to the top here. I can see that all the 18-year-olds are first, and then we've got some 19-year-olds, etc., and 20-year-olds. We can order on multiple variables. So we can arrange on gender and then age. So the order of variables that we put them in will be the order they are arranged in. So we've got our females first, because that's how the gender variable was defined as females as the first level, and then female 18-year-olds, then female 19-year-olds, etc. And then you can also order by descending by just putting this DESC function around the variable you want to be descending by. So if you want to order by ascending gender, in this case where females first and then males, but then descending age, so oldest age first, you have the same order of things, but you just put DESC around age there, or technically put age in DESC for descending. So control enter there. You can see we've got females first, but it's starting with the older females. So these are a couple of the basic verbs of data wrangling with dplyr. And it really just shows some of the basics of Tidyverse in that we give a whole data frame as the argument to the function. We don't have to refer to variable names using quotation marks. And the output of each of these functions is a whole data set. We're going to be doing some more videos on Tidyverse, but this is the end of this one. So thank you for watching. Try the examples in the booklet. Tidyverse, just like the rest of R, the best way to learn it is by doing it. So get out there, try those examples and the activities, and see you next time.